Who would believe that all the happening in the digital world at the end it is 0 and 1? Is it reasonable that receiving a WhatsApp message is basically 0 and 1? Digital systems have such an important role in everyday life. We can find digital systems in almost every technology that is daily used. Think about smartphones, digital payment, medical devices. Digital systems are different from analog systems due to the fact that they use binary number. Binary number is one of the representation of digital system using the two digits 0 and 1. In general, a number expressed in base R system has coefficient multiplied by power of R. Also, there are many other number systems, for example, decimal, octal, and hexadecimal number systems. Binary number. A binary number is a number expressed in the base 2, which use only two symbols, typically 0 and 1. Binary value can represent abstractly by digits 0 and 1. Sometimes we use words like false and true, low and high, on and off. So why binary system use only two digits 0 and 1? Well, because in digital system any logical circuit has only two states, which are on and off. It can be useful to know that 0 refers to the input low, and 1 refers to the high. Let's take a look to the decimal number here. It's 9. We know that decimal numbers start from 0 to 9. To get a large number, the rightmost digit resets to 0, and the immediate digit to the left increases by 1. Similarly, in binary number increase, but the reset happens with every other increase. To convert binary number to decimal number, we use expansion method. In this method, the given number is expressed as a summation of terms, each of which is a product of a bit, 0 or 1, and a power of 2. The power of 2 is determined from the bit position. Let me explain the following example. This is the three-digit binary number 101. Each of these digits can be also called a bit, since a bit represents a 0 and 1. Now, this three-digit number equals to 5 in decimal number. The first place here, it's ones place, just like in decimal. Now, there is a 1 here, so that means we are gonna multiply 1 times 1. The second place, the second bit here is actually the 2's place, and there is 0, so it is 0 multiply 2. The third place is 1, and it is the fourth place, so 1 multiply 4. So we have now 4 plus 0 plus 1, which is 5 in decimal. So each of these places represent a power of 2. The first bit is 2 to the 0 power. Is 2 to the 0 power. The second bit is 2 to the power of 1. The third is 2 squared, 2 to the power 2, which is 4, 2, 1, and so on. Arithmetic operation on binary number. We have addition, subtraction, and multiplication. The first one is addition. The sum of two binary numbers is calculated by the same rules in decimal, except that the digit of the sum in any scientific position can be only 0 or 1. and the carry obtained in each scientific position is used by the pair of digit one scientific position higher. Let's solve this example. 1 plus 1 in binary is 2. So we write 0, 1. 1 plus 1 is 2. 1 plus 1 plus 1 is 3. In decimal, represent the 3 in binary 1 by 1, 1. So 1, the carry obtained here 1. 1 plus 1, 0, 1. 1 plus zeros is 1. And 1 plus 1, 0, 1. The subtraction is more complicated. The rule is still the same as decimal, except the borrowing decimal systems as 10 to digit. But here in binary, they borrow in each scientific position as 2. Let's solve the example. So we have 1, subtract from 1, which is 0. So we have 0, so subtract 1 from 0, it cannot be. So we use the borrow system, add 2, borrow from here. So subtract 1 from 2, it's 1. Subtract 1 from 0, it cannot be. So 0 and borrow is 10. 2. Subtract 1 from 2, it's 1. 0 from 0, 0, 0 from 0, 0. And 1 from 1, it's 0, 2. The multiplication is more simple. The multiplier digits are always 1 or 0. Therefore, the partial product are equal either to shifted left copy of the multiplicand or to 0. Let's solve the example. So, the first digit here is 1. Multiply this number. It's going to be the same thing. Copy. Then shift. The second number is 0, which is 0. 0 multiply anything, it's 0. Shift it again. And we have 1, so the same thing. 1, 1, 0, 1. Then add it all. It's gonna be 1, 1, 1. And 1 plus 1 is 0, 1 is 2. Here 1 and 1. Well, this is the end of our topic. Thank you for listening to me. And if there is any question, you can contact me via email. Thank you.